Okay, in this video we're going to solve a few examples of differentiation questions, finding derivatives. So, okay, in the first one we've got fx equals to 4x squared. So now what we do, as we said before, is we take one power of x, so the power of x, we subtract 1 from the power of x, and multiply the original power to the coefficient of x. So we're left out with 4x squared is going to be the derivative, which is dy dx equals to 4x squared. So the 2 would multiply with 4, so it's going to be 8x, and then we subtract 1, which is going to be x to the power 1, but we usually don't write the power if it is 1. We're going to move to the next example, which is fx equals to 2x to the power 3. Again, we exactly do the same thing. We subtract 1 from the power, from the original power of x, and multiply the old power. What we do actually is multiply the power first to the coefficient and then subtract 1. That's actually, I think that's the better way of saying it. So we take the power of the x, multiply the coefficient, so again dy dx equals to 3 times 2, which is 6, and then we subtract 1 from the x, which is in this case going to be 2 because it was 3. 3 minus 1 is 2. Let's do a couple more examples. fx equals to 7x plus 3. Again, we've got 7x. The power here is 1. So if you subtract 1 from the power, is going to be x to the power 0. Anything, as you know, anything to the power 0 is 1. So basically we're only left out with the coefficient. So dy dx equals to coefficient, multiply with 1, which is going to be the same. So yeah, x to the power 0 is 1, so 7 times 1, you don't have to write it. And you know, for the constants, as we said before, the constant doesn't, the derivative of any constant, if there's no like x or y, any variable, just constant, any derivative of constant is 0. So we don't have to write plus 0, just leave it as it is. And for this one, we've got a fraction here, but dy dx. Actually, there are 2 ways of solving it, but I'll show you both ways now. So if you want to do it, it's a harder way, but it's more efficient though, if you're not used to the other way, which is you convert the form of the fraction. So 1 over x, we can literally write it as x to the power minus 1, because that's what the fraction is. If x to anything to in the denominator is to the power minus, but in this case x to the power 1, so, and the denominator to the power minus 1 only. So after that, we literally use the same procedure as we did here. X to the power minus 1, we take 1, we multiply the power times the coefficient, which is 1 in this case, and then subtract 1 from the power, original power. Sorry about that, become a little bit messy. So yeah, minus 1 times x, which is minus x, and then in the power minus 1 is minus 2. So the derivative of what dy over dx equals minus x to the power minus 2. If you want to write it in a fraction form, it's going to be minus 1 over x squared, because here is minus 2. So we write it in the denominator with 2, because it's, if you want to put it up, we put it in minus, we change the sign. If you want to put it down, we revert the sign back. So minus x to the power minus 2 is 1 over x2. There's another way of solving this question I told you earlier. 1 over x, what you normally do is literally just increase the power of the denominator and change the sign. That's what I do. If it was in the denominator, yeah, only in this case, in the denominator, increase the power of the denominator and change the sign. So basically 1 over x, increase the power, becomes 2, and change the sign. Here is positive, you write it as negative. Either way, it's up to you, but this one is more like for explanation. This is doesn't make more sense. But in exams, you might want to, you don't have time, you just want to solve it quickly, so you go from you use the other way, the shortcut way.